Welcome to part 9 of coding Slither.io in Python, and this tutorial series is almost done. I'm excited to announce that. When you run, we've accomplished a lot with this program so far, and it's looking a lot like Slither.io. And I only anticipate a few more videos to come after this one. This one will be focusing on combat between the snakes, because as you can see here with the snakes, they do not die when they collide, and that's something that we want to fix here. But before we do that, I want to illustrate something we're going to do to optimize our code a little bit. And in a previous video, you might recall I talked about an inheritance, which just means you have a parent class. In our case, it's the snake class. Snake. And then the snake has a bunch of shared methods. But then there's also two children classes, the player and the AI. And this is how our game functions. They both inherit from snake. The player and the AI are both a kind of snake. And of course we do have the snake inheriting from another class called object, like that, but we're not really concerned about object for now. But this is our inheritance structure. We talked about it in previous videos, and what I want to do is take this inheritance a step further. Recall in our main.game.py file, up at the top, we have a list of AI, and then we have a player variable, and they're separate. And they're separate for a reason at the beginning of this tutorial series, but with our inheritance, that's making less and less sense. Both the player and the AI are in the snake class, and it would honestly make more sense to combine them. So what I mean by this is we have our list of AI in our code. I'm just going to visualize it like this. We have a list of AI in our code, and it's just a pretty simple Python list. So we have AI in the list, and then we have the player variable that's separate. And now whenever we want to update and draw all the snakes, we have to update all the AI separately and then update the player separately. Same with drawing. When we want to draw all the snakes, we have to draw the player separate and draw all the AI separate. And we can see this separation in our code. In our update function, the player gets updated here, and the AI get updated here. Rendering, the player is drawn here, the AI are rendered here. But it would make more sense if instead of this duality, we would just replace this structure, these variables, with a new list, but not a list of AI, a list of snakes, like this. And this is going to be much better organization in our code. It means that when we want to modify the player or update the player in AI, instead of separately calling these functions, we can just all do it from one for loop that will handle all the snakes. So that's what we're going to start this video with. We're going to convert our AI list and player variable to just one list of snakes that will encompass them both. So that's what we're going to start with. And the change is going to be pretty easy to make. I'm going to start by just changing this name to snakes for our AI list, because this list is going to eventually involve the player. And I'm not going to delete the player variable right away. I might need this later, but we might delete it in the future. So snakes will be all of our snakes, including the player. The player will be somewhere in this list. So here in the init function, right with this for loop, for I in range number of AI, this is where we create all the AI and we add all the AI to the snakes list. So let me change that name to snakes. And also every other occurrence of self.ai needs to be replaced with self.snakes. And I may make a mistake while doing this if I even miss just one of them, so hopefully that won't happen. Alright, there. So far the variable is renamed to snakes. Now back here in the init function, all the AI are added to the list of snakes, but we need to add the player to that same list. So for convenience, I'm just going to make the player the very first snake in the list. Self.snakes.append self dot player. So the way our structure is going to work is we're going to have this list of snakes, but the first one is always going to be the player. And that will be useful in case we ever need to quickly access the player and we don't have to go through each and every one of them. We'll just memorize the fact that the player is going to be the first one. So here we add the player to the list. And now what we can do here is start getting rid of those extra functions we have for the player and the AI. So AI update, this is just going to be snakes update, and this will update the player, which means we no longer need this player update here. So I could delete this, but I'm not going to delete it for a reason I'm going to say in just a second. Let's skip over to update and go down the render. So this is where all the snakes are rendered. This is where the player's rendered. We can delete this. Now, the reason I was able to do that is because the player's drawing parameters were the exact same as the AI's drawing parameters. Let's take a look at update. That's not the same thing. So when I update my AI, the AI needs orbs. The AI needs orbs so that it can find the nearest orb. We did that in a previous video. It has the list of orbs so that the AI can calculate the direction to the nearest orb and move in that direction. But the player doesn't need orbs in his update function. He needs window dimensions in order to follow the mouse around. So right here, if I just delete the player update function here, then when we get to this for loop, it's going to call snake.update, and the first time that's going to be the player, so it's going to be the player.update, and it's going to pass in the wrong parameter, and we're going to get an error here. So to fix this, I can go ahead and delete the player.update function call, but I need to make a modification to player. We need to get rid of this requirement for window dimensions, and we also need to replace this with orbs. We want the player's update parameters to be the exact same as the AI update parameters so that one for loop can execute them both. So for the player, this window dimensions, we need to have window dimensions to calculate the distance, or not the distance, but the direction to the mouse. And this was a really complicated math video. You can review it if you want. I don't remember which one it is. But instead of having window dimensions be a parameter for update, we can simply make it a private variable and pass in this private variable in the player's constructor. So after file path, I'm going to pass window dimensions. So this is a cool trick that will let us get around this parameter. Now we no longer need this parameter here, or here, or here. Now this is a private variable, so our update function is now independent. No parameters needed. But I gotta remember, when we calculate the direction, window dimensions needs to be replaced with self.windowDimensions, since we just now made it a private variable. And was that the only occurrence of it? I think so. Alright, so that handles that issue. Now the player's update function no longer needs the window dimensions, but we still have this discrepancy between the player update function and the AI update function. Remember, we want to combine our player and our AI in one nice organized list. And we want this list to be able to run all their update functions in just one for loop. But we can't do that until their update functions are the same. So now what we can do is we can just simply pass in orbs as a parameter for the player update function. Now, does the player need the orbs? No, just the AI. The AI uses the list of orbs to track the nearest orb. But by passing it in as a parameter for player, even though it's completely useless inside the player, we've now made this update function the exact same as the AI update function, like this. So now in our main game, it should be working. I already deleted the player update, and when I run this, hopefully I did not make a mistake, and I did make a mistake. Oh yeah, window dimensions. We just made it a parameter. Now we have to, we made a parameter for the constructor. Now we got to pass it in. So after the player's texture, we're going to pass in self.window dimensions. And now hopefully it'll work. And it does work. And it works the exact same as it did before. This is the same result as at the beginning of the video, but now we have more organization. We have a list of all the snakes, and this includes the player, which means that we can use just one for loop to update them all at once. Where is it? To update them all at once and to draw them all at once. And this is much more ideal. Now, the one other thing we're going to do before we finally move on to the combat portion is this snake. We're going to go to the snake file, and we have a lot of code from previous videos. This code right here, all that does is it moves the snake in whatever his direction is determined to be. And then we have the code that adds a segment whenever needed. That's when the score increments by a certain amount. This should not be hard-coded. I don't know why I did that, but I won't fix it now. And then we have a for loop to update each segment so that the previous segment follows the next one in line. If you recall, that's just like this. If we have, this is the snake here. It has the head, and then segments following it. And all this for loop does is it tells each segment to follow the next one. So if this is the player, this segment will follow the player, this segment will follow this player, and that's how we get the snake movement in our code. So before we go on to adding combat, this needs to be organized because this code is long and it's a mess. So we're going to use functions. I'm going to start with this code that adds a new segment, and I'm going to put it in an add segment function. Define add segment, and I don't believe any parameters will be needed, which will make it really convenient. Yeah, see, the update function has no parameters, so this portion certainly won't. And that makes it really easy because I can simply cut it out and paste it under add segment, and of course replace that with the function call, self.add segment. We're going to do the exact same thing. I'm going to call this update segments. Define update segments. No parameters needed. I can just cut, paste, and add the function call. Self.update segments, and I'm going to perform a quick test just to make sure that nothing went wrong in that process. And once again, we're still at the exact same spot we started, but now our update function is a little bit organized, or a little bit more organized. So now the next thing we're going to do is finally add some of that combat. And here's how the combat system is going to work. So I'm going to clear this, and the combat system's actually it's not too terribly complicated. It's just going to work like this. Imagine, and I'm going to draw this terribly. I already practiced recording this video earlier, and this drawing didn't get any better each time. But imagine this is our list of, this is our game, and we have all these snakes here. And let's say the player is this one here, or just any snake. So we have all these snakes in the game. They're spread out like that. Now, what we're going to do with this snake is when we update him, we're going to make sure his head is not touching any of the other body segments of the other snakes. Because when the head touches any of the other segments, we need to kill the snake. But this is going to run into an immediate performance issue, because this head is going to check this segment of this segment of this snake, then this segment, and once the head has checked every single segment on this snake to see if it's touching any of them, then it's going to do the same with this snake. It's going to check each and every segment. So if I have 10 snakes and each snake has 10 segments, I'm now performing 100 checks just to see if this snake should die or not. And this is going to create a huge performance issue. So here's what our workaround is going to be. We're only going to check the segments of the snakes we are close to. So we're going to set a certain maximum distance. Like, I'll say just, why is it covering that? I don't like that. We're going to set an arbitrary max distance. And that maximum distance is going to be equal to, I don't know, just some large number like 500, something like that. And now we're going to do a calculation and see if the head of this player is any closer to the head of another player than this maximum distance. So this snake here, or player, it doesn't matter, is going to check the distance between its head and this snake's head. And if this distance is any bigger than max distance, we're not even going to bother checking, because that's just a waste. The snake is nowhere near. There's no way we can possibly get killed by it. So we're going to do this with all the snakes in the game. We're going to see, is this head close to this head? Nope. Then we're going to skip that check. We're going to skip this check. But then right here, this head is pretty close to this head. So the distance between this player head and this snake head is going to be less than our maximum distance. That's when we'll perform the checks. See if the head is touching any of these segments. So now we just saved a whole lot of extra calculation by doing this clever logic of, well, not to actually praise my own code. I'm pretty sure I learned this from someone else. But this is going to save a lot of processing. So that's what we need to do. So first thing, we need to pass in the list of snakes to this update function, update snakes. And before I even forget, we need to do this for AI and player. Remember, the player calls the snake update function, and the AI calls the snake update function. So they're all going to need snakes. So AI update, snakes, and then add in snakes here. The player update function, add snakes, and then add snakes here, like that. So now we have snakes passed in properly. What we're going to do is we're going to iterate through every single snake, and we're going to do just that. We're going to see if the head is any further away than the maximum distance. So let's create that distance. Max check distance is equal to 500. So this means if the snake is any further than 500 pixels away, we're not even going to bother checking if the head of this snake is touching any of its segments. It's too far away. We're going to save time. So maximum check distance up here. And what we're going to do, and by this point, you should know how to calculate the distance between two objects. First, you need the direction vector, target minus start. So the direction is equal to the snake.rect.x minus self.rect.x. So the snake that we're looking at, our target snake over here, minus this current snake over here. This is the same formula we've used several times in previous videos. Your target position minus your start position. That's how you get the direction vector that points to your target. So there's the x, let's get the y. Snake.rect.y minus self.rect.y. So there's the direction. And now that we have the direction, which is just our useful little arrow that points from here to here, gives us the direction. And I'm going to draw it as an arrow like that. Then, as you know, the way we get the distance is we use the formula, which would be for the direction x squared plus direction, create new space, direction y squared, and then taking the square root of this whole thing. That is the distance in pixels. So we take the direction vector and we apply this formula to get the distance. It's just the normal distance formula. distance is equal to, and the square root is the same as raising to the half power. I might not need to explain this for a lot of you. I'm just doing it anyways. Direction 0 squared plus direction 1 squared, like that. So now we have the distance. And here's where we're going to do the check to see if it's too far away. If the distance is greater than the max checking distance, then this snake is too far away and we should skip this snake in the for loop. Now, luckily Python has a really convenient keyword that will let you skip to the next item in a for loop, and that's simply continue. So the rest of the code here, where we check the segments, if this continue is run, that's going to get skipped, and we're just going to skip to the next snake. But if this isn't true, if the snake is in the target range, then we can begin to check the segments for segment in snake.segments, like that. And what we'll do here is we're going to see if, and I believe we're going to do this, oh no, we'll use the collide function, that's right. If, remember Pygame has a really useful collision function to see if two rectangles are touching. If self.rect.collide rect and then segment.rect. This function will check if our rectangle is touching the segment rectangle. So if we're touching the current segment, then what we're going to do here, we should kill the snake, but we're inside the snake. That's not a good place to do it. So what we're going to do is return true if this snake needs to be deleted. And if we get through all of this, no problem, we'll return false. This snake gets to live another day. So what this means is when this function is now going to return a value, and if this snake is touching any of the segments at any point, it's going to return true. And in our main game program, we can check if that function returns true. And then we'll handle the deleting there. But for now, and then if it returns false, we obviously don't delete. But notice we do got to change one thing. So in our main game, we have snake in self.snakes, and we have our, sorry, wrong one. Here's the loop, snake in self.snakes. This is where we call the update function. This update function is not the snake update function. Remember, we are using inheritance. It's actually going to be the player update function and the AI update function. Now, their update functions call the snake update function, but this update function belongs to the player or the AI, not the snake. So if my snake update function is returning true or false, I actually have to catch that in my AI update function. This is where we call the snake update function. We're going to return this. And same thing in player. Because if we don't do this, then this return true means nothing, because true is just going to get stuck here, and we're not actually going to have any way of taking that true value and giving it back to main game, because we have the AI update function that's kind of in between the main game and the snake. So I wasn't even planning on illustrating this, but just to make sure this makes sense, we have main game, and then our AI, and then our snake. Now the AI has an update function, the snake has an update function, and the main game is looking to see if the snake's update function returns true or false, so that's how we know if we should delete the snake. But when the snake update function returns true, that true value goes here, AI.update. And before I had this, it would just kind of stay here. That information would have no way of getting back to the main game because we weren't returning it. But when I add return the result of the snake update function, now that true false value can go from here and now go to here. So now we can process it. So that's why I added return here and return for the player. So now let's actually process that. In our main game, we now have a way of knowing if the snake should be destroyed. So we're going to say if the snake.update returns true, that means it needs to be killed. If you want, you could make it false just because false seems kind of negative and killing a snake seems negative, but I'm going to make it true for now. If the function returns true, we need to kill the snake. And all I'm going to do is, for now, this is just going to be my temporary thing. We're just going to delete it. In slither.io, when you kill a snake, it turns into a bunch of orbs that can be eaten by other snakes. That's the whole point of the game. But for simplicity, we're just going to delete it all. So first we're going to delete the segments. Snake.segments.clear. The clear function will just empty a list. And now we're going to delete the snake. Self.snakes.remove snake. Like that. So we delete the segments and then we delete the snake. And I'm not even sure if I need to delete the segments separately. Probably if I just delete the snake head, the segments, since they're stored inside of it, will go with it. But let's go ahead and give it a test run. It's very possible. Ah, man, I was going to say it's very possible I made a mistake, and I did make a mistake. Oh, and it's actually simple. We need to add in the snakes here. Self.snakes. Remember earlier we passed in the snakes as a parameter, and we did the same with the AI and the player. Well, I just simply forgot to add it in here. So orbs and snakes. Let me make sure that order is correct. It is orbs and snakes. So now I'm going to run it. And they are deleting not quite the correct reason, actually. I'm going to go ahead and pause here. This has been a pretty complicated video to learn, so I'm going to pause here and figure out what the issue is. Alrighty, with a newfound confidence in my ability to record the rest of this video, I found out what the issue was. So we're just getting AI just randomly dying like that, and I don't really like that. Here's the problem. The problem is I need to also check if the distance is 0. So we should not check any collisions if the distance is either too far or the distance is exactly 0. Now, why is that the case? Well, here's why. Back to my list. I'm going to illustrate again with paint. Hopefully you all are visual learners. I'm a very visual learner, and I've known this to help some people. Hopefully you all find it as helpful. So we have a list of snakes like this. And what we're doing is we're going to have each snake check all the other snakes in the list to see if they're touching. So this snake is going to run a for loop to see if he's touching this snake, or this snake. And then this snake is going to run a for loop to see if he's touching this snake, and this snake. But there's a problem. When I passed in the snakes list, we passed in the entire list, and we iterate through each and every snake, which means if I am, say, on the second snake in the list, and I'm trying to see which ones I'm touching, since this for loop runs through every single snake, and this snake parameter contains every single snake, what happens is this snake here that we're checking, he checks this snake, and then he checks this snake, which is himself. So he just now checked if he's touching himself. And then this snake and this snake. So this is the problem. Because really, the distance between this snake and itself is 0. Is 0 less than the max distance? Yes. Which is then he will go and see, am I touching the segments of that snake? Well, this function is going to return true because this rectangle is the same as this rectangle. He's checking to see if it's touching itself. And so we're going to return true. And it's going to delete itself because as soon as it adds one segment, it thinks it's dead. However, if we check to make sure the distance is not actually 0, because that's how you get a distance of 0. If you do that target position minus start position formula on yourself, well, these positions are going to be the same, which means the result is 0 and the distance is 0. So checking to see if the distance is 0 is how we make sure that this snake doesn't check collision with himself, but rather he skips himself and just goes over to the next snake. So once you add or distance is equal to 0, then we see the results that we want. We have the snakes. I'm just going to collect segments first, and now I'm going to try to find a snake. I'm going to run it again. That's taking too long. Now we're getting the correct output. I saw it just a second ago. I need to find another snake. And basically when I touch that snake, the entire thing just deleted. And that's correct. That's exactly what should be happening with this code. So now the final portion of this video is having orbs appear instead to replace when the snake dies. I'm going to see, we want orbs to be there to reward for that wonderful kill. So we're going to actually, let me go to the main game. The final part of this video, almost done with the combat. So here, instead of just deleting everything, we're going to do something slightly different. We're going to iterate through each one of the snake's segments. So now that we've determined this snake needs to die, it touched another snake. So now we're going to iterate through each of his segments. And now we're going to delete each segment, yes, but we're going to replace that segment with an orb right in that same position. So we're going to create a new orb right there, and I'm going to be kind of lazy here. I'm going to go to our init function. Here's where we created the orbs. I'm going to borrow all of this code, basically. This is our code for creating the orb, and I'm going to paste it there. So, a random x. Well, we're no longer doing a random x. We want the exact same x position as the segment. So this orb, I'm just going to replace this with self, not self. It would be segment.rect.x. The starting y would be segment.rect.y. And I can get rid of this random y thing. We no longer need that. Random radius. I don't want the radius to be randomly sized or the size of the orb to be random. I actually would rather just have it be the size of the segment, what the segment already was at. So I'm going to say random r is going to be at, and we can either use one of our constants for this, the size of the player. That's going to be the size of the segment here. Let's see, player start x, player. Here it is. Start width, start height. So I'm going to actually use this to be the size of the new orb. I want the orb to be the exact same size as the segment it is replacing. So start width. And also recall that the segments are always the same size as the player. So this is the player's starting width, which is also the segment's width, which is now the orb's width. So this is not a random r. This is just your width. I don't know what else to call it. Maybe W. I'll call it size. There we go. Random texture. We still do want the texture to be random. Oh, but wait a minute. Now there's a problem. Textures is a list that's undefined in the update function. We had it in the init function right here, and it worked in the init function, but that list doesn't also exist in the update function, so this is undefined. Now, I could simply copy and paste the list and put it inside the update function. But I don't want to do that because that means I'm going to every single frame create and then destroy and then create and then destroy this exact same list of textures. So I want to be a little bit more memory efficient. I don't think this will make a difference in the final output of the game, but I'm actually just going to turn this into a private variable for the whole main game. So instead of just recreating this list every function, we can just use it as a private variable, create it once. So I'm going to delete this line, and now I have to replace this with self.textures. It's a private variable now. And what I mean by that is, if you recall, in Python and pretty much every programming language, if you create a local variable in that function, so like my local variable is equal to 9, by the time this function ends, this variable is going to get destroyed in memory, and this variable will not be recreated until the next time the update function is called. Now, if I have a list of textures and it's a local variable, not, a private variable like what we have here, then it's going to get destroyed and recreated every single frame, thousands and thousands of times. I don't think that's very memory efficient. So to summarize, that's why we're doing this step here, turning it into a private variable. So back to what I was actually talking about, textures is now just self.texture. Did I call it self.texture? I really hope not. This should be textures. So self.textures here, self.textures. Now we create the orb using the new variables we created. This orb is going to be replacing the segment that we're currently looking at, and then we add the new orb. And we're going to do this for every single segment. And once we're done, we're putting an orb where every single segment used to go. We're going to say, hey, orb, start at where the segment, this current segment in the list is. Start at his X, start at his Y, and we're just going to spawn it right there. Now, when we're done doing that, we're going to delete all the segments, and then we kill the snake. And now, hopefully, unless I made a mistake, this should work. Oh, but one more thing. We don't want to just replace the segments. We want to replace the head. So this code would work, but it wouldn't replace the head. So what I mean by that is when I have a snake here and he dies. So here's a snake. He has a head and he has 3 segments, so 4 parts total. Our code only replaces the segments with orbs. So we're going to put a new orb. We're going to put a new orb here, and a new orb here, and a new orb here. But we never put a new one to replace the head. That's going to make a really tiny difference. But for me, I would rather replace the head as well. So I'm actually going to use some of this exact same code. I'm going to copy it again, but outside the for loop. And now I'm just going to do this for the head of the snake. So it's not going to be the segment. It's going to be the snake.rect.x, snake.rect.y. And that will now replace the head. So we have our code that checks to see if the snake is killed. And if he's killed, we're going to replace his head with an orb, replace all his segments with an orb, and then delete the head and the segments. Now, I really hope I did not make a mistake at this point, and it's very possible that I did. So I'm going to run it, and I'm going to see if killing this guy here... Oh, man. Okay, so I killed him, and his segments appeared, and I can now eat the orbs. That's working. I don't know why he just randomly split there. I'm going to run it again, and I'm going to try that again. Hopefully that won't happen again. Oh, we saw a snake die, and we saw his segments get eaten. Let me try to kill this snake one more time. Man, this is... Well, I got killed, but then all the segments got deleted. I don't quite like that. So what I'm going to do to make debugging a little bit easier is I'm going to make it to where the segments can... or actually the orbs, I'm going to make it to where the orbs only spawn in the screen radius. And this we did a while ago, but basically if you only want the orb to spawn anywhere in the screen, then the random.randint is going to be 0 self.windims 0. We're telling it, hey, your X position when we spawn the orb can be anywhere from the far left of the screen, which is 0, and the far right of the screen, which is our window width. So I'm going to do that. I want the orbs to be more collected to make debugging easier. And you can do this exact same thing to test it out. And then I'm going to do the same thing for the snakes. I want the snakes to appear inside the window. I'm going to comment this out, and I'm going to comment this out. This probably didn't need to go inside the video, but you're welcome now it is. I'm going to change the number of AI snakes to 1, so we only have one guy to worry about. So now I can find him immediately, and boom, it worked. I can now eat all the segments. Now, with that guy splitting in half earlier, I'm not really convinced that this video is done. I'm just going to test it one more time. Make sure, I'm going to see what happens when I kill. Oh, okay. So it looked like more segments should have appeared that time. What I'm going to go ahead and do is pause the video and figure out, just to make sure this is all right, because we're close, but it doesn't quite seem correct here. I am happy to say that I both found the error and determined that this video is officially over once I explain it. So good job getting to this point, and I do apologize for being a bit indecisive with the debugging. So the problem is that our player, we can kill the AI just fine, but the AI can't really kill us the exact same way. Like, if my player head runs into the AI, we don't get an extra orb. There should be an extra orb, and that's just not quite correct. I found out that the error was in the orb file. We still are using player and the AI separately. I forgot to update the orb class here, because remember, at the beginning of the video, the focus was getting the player inside that list of AI and combining it together. But here in the orb function, we're still treating them separate. So what I'm going to do is I'm going to delete this player parameter, delete the check with the C in the orb function. We're just seeing if the orb's touching the player, and if so, we're going to add to his score. Well, we don't need to do that with the player separately anymore, because this AI list now has the player. And I'm going to rename it to snakes. So now our orb function, our orb update function, will not double check the player orb. I mean, what was happening was the player was eating the orb that it created when it died, just because we had an extra check here. If that doesn't make total sense, that's fine. Just know that what we need to do is make sure that this orb class uses just one snakes list and not a player and AI. So now let me go to maingame.py, where we're going to write the final piece of code for this program. And all that is orb update. We're just going to get rid of player. And like that, boom, now it's all working properly. If my player runs into the back here, all the segments get turned into orbs here, including the player head. And now that it's working wonderfully, this game has gone quite a ways. I'm going to get rid of all this debugging stuff I added. So now we're going to reintroduce the extra bounds, the larger map in the game. And with that, this video is done. We now finally have some combat in our slither.io function, or in our slither.io game. So from here, there's only a few more videos to add. We'll probably add a start menu, and we need the snakes to have randomized colors, since at the moment they do not. They're all red. But those are all going to be most likely pretty simple videos compared to this one. So thank you for watching, and I'll see you in the next video.